Good afternoon. So, by the end of this lesson, you should be able to find the inverse of a function, and you should also be able to determine if a function is 1, 1. This is the British way, the Cambridge way of saying a function is 1, 1 to 1, but in America we would say it's a 1 to 1 function. So they mean the same thing, they're just written a little different. So let's talk about inverses. So if I have something like an equation that looks like this. You guys have solved tons of these in your life, and we do this following the order of operations. So our first step in doing so would be to subtract 2 from both sides. So we're left with 3x equals 15. This step that we did actually involves inverses. So if I have 2 being added to one side, when I try to eliminate it from one side and I subtract 2, I'm actually doing the inverse of adding. So adding 2 and subtracting 2, those are inverses of one another. Another way that we've used inverses in the past is when we isolate x here, when x is being multiplied by some number. So when I divide by 3, I'm actually performing another inverse operation to isolate x and to solve for x, to figure out that x equals 5. The inverse operation is multiplication and division. So you have done many inverses within your life and maybe did not know that. A real life example of an inverse would be that my sister Gina is about 2 years younger than I am. So I would maybe tell somebody that, oh, I have a younger sister and she's younger by 2 years. Gina might tell someone that, oh, my sister is 2 years older than me. So you notice the words younger and older. These are also inverses of each other. Younger, 2 years younger, or 2 years older, that's another way of having an inverse. So you actually have done inverses many times, so this should not be super new to you. You just didn't know you were doing them. So let's move on and look at what they actually are. So I'm going to just do a quick function review to make sure that you remember what a function is. So a function is something that for every x value there is one y value. So for every x, there is only one y. So a lot of the ways we've talked about this is if I have a parabola here, so I'm going to plot x squared. Alright, so there's, oh, boy, it would help if I could actually land. Oh, goodness gracious, sorry, my pen is not apparently calibrated very well. Or maybe it's the user error. We're going to pretend that's a lovely looking parabola. If you remember from last semester, what we learned is that one of the ways we can test if something's a function from the graph is to draw a vertical line and use the vertical line test. So if my vertical line only touches one point on the parabola at a time, or on the graph at a time, it is a function. So y equals x squared passes the vertical line test. It is a function. Okay, but a function like a circle. Okay, we're pretending this is a circle, even though it definitely does not look like one. Okay, a function like a circle, if I try to pass the vertical line test, what you're going to, okay, and we'll pretend that's actually a vertical line, like so. Okay, what you're going to notice is my vertical line is touched here and here on the graph, or touches the graph here and here. Well, that means that for every x value, there's 2 y values, which means this is not a function. Okay? Not a function. Alright? So, that's just a quick reminder of what a function is. Now, here's what basically happens. With an inverse function, all we do is we switch variables. And what I mean by that is that everywhere I see an x, I swap out for the other variable in my equation, which is typically y, and everywhere I see y, I switch out x. So if I'm trying to find the inverse of, let's say, 3x plus 9, the way I do this, and this is not really tends to be arrow, I'm just saying now look over here. Everywhere I see y, I put an x, because that's what I have here. And everywhere I see x, I put in y. And in math, we always solve in terms of x. So that means we're going to isolate y. Okay. So I'm going to subtract 9 from both sides. So I end up with x minus 9 equals 3y. And my last step is to divide both sides by 3. So I end up with 1/3 x. That's x over 3 is the same as 1/3 x minus 3 equals y. These two equations are inverses of one another. Okay? So let's try again with a more complex equation. So let's say I have y equals x squared plus 16. Okay? So my first step is to do what? We're going to swap x and y. So I'm going to just write that this is the inverse over here, and we'll get to notation in a moment. So x equals y squared plus 16. My next step is to actually subtract 16 from both sides because I'm trying to isolate y. Alright, and then finally I'm going to do a square root. And remember, when I'm the one doing the square rooting, I need to have a plus or minus because I don't know if what's going to be square rooted is positive or negative because I'm not sure, because a square can hide a negative inside or it can hide a positive inside, but when it's squared they both come out positive. So my answer here is x minus 16 equals y, and these two are inverses of one another because we swap the x and the y. Now if we were going to do this with points, so if I asked you to find the inverse of 3, 6, well, we do the same thing. The inverse of 0.36 would be 6, 3, and so on. The inverse of -2, -5 would be, can you guess? Swap x and y, -5, -2. Not too bad. Okay, so let's talk about notation. So you have actually seen inverse notation. So when we had something like this in our trig unit, the way we solved this function was we said the arc sine, or the inverse sine of root 2 over 2 equaled x, right? Well, this little power of -1, which is not a power, it means inverse. This is one of those interesting notations in math that can be kind of misleading. This just means inverse. So if I were to say I have function f, right? If I wanted you to find the inverse, I would say find the inverse of function f, just like that. Or if I had f of x equals x squared, right? These are really the same thing, like we learned. This is just the more mathematically correct way to name a function. I would say this. So remember how we have the -1 that looks like an exponent between the sign and what it is and what's inside? Well, we do the same thing with function notation. So we would say find the inverse of f of x, or find the inverse of function f. So that's the notation. And we have one other thing to talk about in terms of functions, and then we're going to actually practice a few things. So one-to-one functions or one-to-one functions, there's a requirement for something to be categorized as a one-to-one function, and that is the original function and its inverse must both be functions. So you may be surprised to know that that actually is not always possible. So if you think of a graph like, okay, I'm going to sketch a graph of sine. It looks like this, right? Okay, if I were to continue this on, well, the graph of sine and cosine are already functions, right? But if I were to, say, switch the x and y values, I would end up with, let's see, I would end up with a function that looks like this, right? Okay, that's really bad drawing. But what you're going to notice is that it does not pass the vertical line test. So sine and its inverse, well, they don't meet the one-to-one requirement, so they are not actually a one-to-one function. Okay, and then on all one-to-one functions, the original function and its inverse are reflections of one another about the line y equals x, always. Okay? So for 1, 1 functions, all 1, 1 functions reflect about y equals x. So let's go ahead and look at what this is on a graph. Okay, so if I have a 1-to-1 function, the first thing is every line is a 1-to-1 function, right? Because, well, for obvious reasons. So if I have y equals 2x, what I'm going to know about the inverse is that we would have half x equals y as the inverse, right? Say swapped x and y and then solved for y. So I'm going to move this over here. Now we're going to graph this. Okay, and boy, I cannot draw straight lines today. So instead of, okay, so what I'm going to do is I'm just going to go ahead and plot this. So my y-intercept is 0 here, and my slope is 2. So there we go. Okay, let's see if I can draw a line that's straight. Pretty close. Okay, so there we go. There's this one, and I'm going to just sketch this one. And so what I want you to notice is at 1, 2, that's a point. I'll show you what happens here. Okay, I'm going to do this one in maybe blue. So we'll do this one in blue. So again, my y-intercept is 0, 0. That doesn't change, but my slope is half. So that means up 1 over 2, up 1 over 2. Or we could even say down 1 over 2. Down 1 over 2. And then I'm going to connect these points like so. Okay, and then I'm going to look at 1, 2. The inverse should be 2, 1. So let's just double check and make sure we have a point there. And we do, so definitely inverses. What you're going to notice is what we talked about in the last slide. If we were to draw a line through y equals x, that's this pink line that I'm sketching in, if I were to fold my graph on this line, what you're going to notice is each half is going to fold. So the yellow would fold on top of this part of the blue, and the blue would fold on top of this part of the yellow. Okay? That's an indicator that this is a 1-to-1 function. So that's what you're always going to notice with those. Okay?